Hi, this is your host Swapnil Bharti, and we are here at the Red Hat Summit. And today we have with us one of my favorite, person, Limor. You started Adafruit. I am a user myself.
Good.
I make a lot of things during Halloween. I 3D print a lot of things on a fully open source 3D printer, and then I use, all the LEDs and all those, Arduino-based things there too. Mm-hmm. So it's really great to sit down and talk to you. So it's like professional and personal. There are two, pleasure. This is a kind of different experience for me.
This is like your most fun podcast.
Exactly.
Okay.
So first of all, I would like to know how and when you started this.
So I actually went to MIT, which is not too far from here. We're in Boston right now, if people weren't aware, at the Red Hat Summit. And I went to school and I studied electrical engineering and computer science, which means I did a lot of like math and Fourier transforms and like MATLAB and stuff, and that was really cool. But what I really like to do is build stuff. Like you're an electrical engineer, you want to actually build stuff. Just like when you study software engineer, you learn design patterns, but eventually you're like, I want to write a game. So I would, instead of working on the homework and thesis stuff I was supposed to be doing, I would design projects in my dorm room. So I made an MP3 player. That's actually before the iPod. So like you could build your own MP3 player with just chips, or you could build like a GPS tracker, or I built like light toys for Burning Man. And we'd publish these projects on my website. I had like a website at the Media Lab, and I'd publish these projects and all of the source code that goes with them. So this was kind of open source hardware, but at the time, like nobody really, it wasn't a thing yet. It was like, oh no, you just publish everything and you give it all away. So I was doing that, publishing the CAD files, the schematics, the firmware, which was like a PIC assembly, and just sharing how I would build an MP3 player. And then I'd get people from around the world, because there was blogs posting this stuff, and they'd say, hey, I really want to build this too, but unlike software, you can't just type in make, like config. You actually have to like buy all these little parts. And with hardware, they don't all come from one place. So you'd order the PCB from one place, and you'd order resistors from another place. You'd order this special MP3 chip from a third place. So it actually kind of gets very complicated very fast to like get all these components. So people would email me and say, hey, can you sell me a kit of parts? Basically, everything together in like a little tar ball, but it's hardware. And you get in a package, then you could put it together. And so I kind of didn't want to do that at all. But then eventually I relented. And so I started selling a couple kits. Every week I would ship out a couple kits from the local post office. And then I just kind of started doing that as my job. And so that was like 13 years ago. And now we have like 4,000 products in the Adafruit shop, from kits to hardware to DIY Linux computers, kind of everything that people can use to build what I think are really cool projects.
And it has evolved, I think 1 or 2 years ago when on Nintendo Switch, the Zelda game came out, and one of your team members, they were 3D printing the whole sword.
Yeah.
I also actually printed it in my office.
Yeah.
With all those NeoPixel lights. So where you started versus where it is now, how do you kind of keep the excitement going on? Because it's all about basic electronics, if you look at it.
It's really still the same core electronics, but then what we're doing is we're trying to reach more people.
Exactly. Mm-hmm.
Because when I started, the kits were very, like, to build them really, you had to be an electrical engineer. Like, you had to have a PIC programmer or a parallel port. These were very expertise-based kits. Maybe they had like 300 parts in them. And you could reach a certain subset of the population, but a lot of them weren't beginners. And there were a lot of people who were not being served by this. They wanted to do electronics, they didn't understand how to get there. So actually the Zelda sword is a really good example, because we're doing a lot more cosplay projects. There's a lot of kids, even adults, who love cosplay. I mean, like, what don't you love about cosplay? Everybody loves video games. You want your own Master Sword or like Ancient Sword from Zelda. And you want to become these characters that you spend 40, 50 hours with. You can dress up as them, but a lot of games now, they have lights or robotics. And so us being able to take electronics and show people, hey, you do cosplay, so you're sewing and you're crafting, you're doing foam. You're already very skilled with working with your hands. Let's show you how electronics can be just as easy to work with as EVA foam. Get these parts and maybe you clip them together, use alligator clips. Maybe you do a little bit of soldering if you were more advanced, and then 3D printing, as you said. And you end up having this like huge pot where you get all these technologies together, you mix them up, and you can build almost everything. So cosplay is an excellent example of that.
I mean, cosplay is more a cultural thing, but what is your mission? Okay, this was something you started personally. You were interested in electronics, but is it that to kind of not educate but make people aware of? Because like we live in a world of iPads, where kids swipe and that is their access to technology, which is not technology, which is a consumption device.
Yeah, you don't even know how to fix your iPad if it
Exactly.
breaks. You're like, this is a glass slab. I mean, it's beautiful.
It's consumption, it doesn't teach you or it doesn't give you. So what is your actual mission, have you ever thought about it or?
That's would be funny if I said no. So I think the mission is to teach people to share technology and show people how much fun and exciting and creative it can be. I write a lot of code, but at the end, there's something really beautiful and creative. And I think it's fun to see people sharing the technology. One of the things I love about hardware, software that has this to an extent, but hardware even more so, you can pick it up and actually show somebody. You can share it with people. You can take it out and you can wear it, at Burning Man or at a cosplay convention. But it also helps people. So for example, in the last year or two, actually, one of the things that we've done a lot more of is assistive technology. So assistive technology, people who don't know what, it's called AT for short. There's people who, maybe they need help, opening cabinets, or they need voice control because they can't use buttons as easily. So they just have technological needs that, as buttons get smaller, as iPads become more, touch-based, maybe they don't have that ability to control the technology. And so assistive tech kind of bridges that together. So maybe the buttons are really large. You saw this with the Microsoft XAC, their accessibility controller. How to get people to be able to play video games without having to hold these extremely delicate controllers. So AT and open source hardware go together really well, because everybody who needs assistive technology usually needs a very specific type of AT. Everybody's needs are a little bit different. How hard they can press the button, or their range of motion, or how many buttons they can press, or what kind of voice control they can do. So if you have closed source technology, you're stuck. It's either off the shelf and you have to figure out how to make it work for you, or you have to hire somebody to custom build you the technology, which is usually outside the range of most people. And a lot of people with AT, they don't need AT. They don't have huge budgets to get this technology built. So open source hardware is this perfect middle ground. It allows you to customize. Anybody can do it, and it's open, so you can keep hacking and adjusting it. So as people's needs change, you can tweak the code. And so we're actually seeing a lot of AT users and people building for AT using open source hardware because, again, it's not something we originally designed it for, but it fits so well.
I will come back to the mission question. One thing you mentioned was, open source. People can, hack, they can improve, but how it benefits you also, because when people change your code, it's open source, so they may also put a patch up there. So does it work, in the other way around, that you also see, hey, I did not even think about, this use case, and they're doing it?
Absolutely. Yeah, we have a weekly show called Ask Engineer. So every Wednesday, just like you have a show, I have a show, and
I'm aware of the show.
We have a show. You watch it. So every Wednesday at 7:30 p.m., we have people from around the world show up, and they're not just customers. It's open to everybody. And what's interesting is people come by and they show off what they're building, whether it's 3D printed or coded or hardware or whatever, or like they're making electron microscopes. And what they're doing, I can't be all people. I don't want to be all people, but everybody has their own community and their own needs. And so they'll come and they'll show, here's what my need, my group, my community, my school, my solar car club, what we're building and how we're using this technology. And it's kind of fascinating because you're like, I wouldn't have thought that this is what people would be using this for. And I think it's good because I think engineers need to be exposed to a lot of use cases, because engineers often we think like, well, I'm going to do it this way because this is the right way, because in my mind I have this model. But if your model isn't large and encompassing, it's really easy to like trap yourself. Like you make an engineering decision and then you end up locking out a group of people. I mean, this happens all the time in engineering. And so one of the neat things about having these weekly shows is that I get to see what people need. And so after they show off their project, I'll ask them like, well, what was the thing that was most challenging for you? And they'll say, oh, for example, before we had addressable NeoPixels, people would wire up LEDs individually. And I remember people would say like, it's really hard to solder thousands of LEDs and not have them break. And so as soon as I saw like, oh, there's these addressable LEDs, that solves this problem. And then you mix those two things together and then you introduce the technology to the people, and they're like, oh yes, this solves my problem, and now I can continue on with the projects that I wanted to build. People know what they want to make. They just don't know how to get the tools and the technology to do that.
Yeah, once I found addressable LEDs, I don't, because I used to make, Christmas lights and Halloween with different kind of LEDs, and now, they have made my life so easy.
It's so easy. It used to be like a total nightmare, and like one wire would break and the whole thing wouldn't work, and you're just, you're kind of like frustrated, and you're like, I'm not having fun. Now it's, some people get angry because they're like, it's too easy, but it's actually great because it means you can take it to the next level.
It saves a lot of my time. Like instead of spending 4 hours in doing that, I can just take it and build something new.
Yeah, now you can like take it to the next level. You're like, okay, now I'm at like I want to make different light shows. I want to make it reactive. I want to connect it to the internet and use cheer lights. So it's neat because you get to do more. And then you have more fun sharing it because you're not like frustrated.
Yeah, you can take it to the next level of what your creativity can do.
Yeah.
Now I'll go back to the mission question again.
Yeah.
You talked about two things. One was to tell people about electronics, and one was accessibility.
Yeah.
So are you working with either any organization, like you mentioned Xbox controller, or it's just you are running your own project, or you work with some companies where you provide them with either models or prototypes, or I just want to understand your engagement with the companies, or you just be an independent.
That's a good question. We do work with some companies. So for example, actually recently NVIDIA released the Jetson Nano, which is this edge computing AI machine learning board. And they actually came to us and they said, we want people to be able to build hardware and robots, but the problem is that there's no like interface, like literally there's no software interface to let people connect to all this hardware. And you've been doing this for so long, what's the easiest way for us to do this? And so we were under NDA for a couple months, and now of course it's all public, which is great. It's part of the deal. It's like, hey, we'll do something in private, but eventually it has to be open source. And then we worked together and I kind of told them, here's the Python interface, here's how to write it, and then it's not that hard, but then once you do this, you're part of this API ecosystem of like Circuit Python libraries, which is like very arcane, but the end result is that thousands of people who are getting these boards can now use the hundreds of libraries that have already been written instead of like constantly recreating all this code, which is another thing that we want to avoid. When we do work with companies, it's usually saying, hey, let's not come up with something new. Let's use something that exists so you don't end up alienating these communities, because it's challenging. There's always something newer and funner and more glossy, but we want to make sure people can actually build stuff too.
Right. And now education part, do you also work with, because this is a very good project for schools, I mean, my son has Little Bits Kit that he builds also. So do you also work with the schools so that, instead of iPads, people have access to actual technology?
That's a good question. So in the US, the school system is very split apart. Every district is a little bit different. And we end up not working directly with school districts. We end up working a lot with teachers, or for example, with Microsoft. We worked with them for a couple of years now with MakeCode, which is their drag and drop programming system. So after Little Bits, this is a really good next step. So maybe your kid can do that. But it's browser-based programming. It's block-based. It's again completely open source. Everything is published on GitHub. If you really want to run the service yourself, go ahead. I don't recommend it, but you can. We had a lot of teachers come to us and they'd say, we want to teach hardware, physical computing in the classroom, because they often have laptops, but I'm a coder, maybe you're a coder. It gets a little boring after a while. You're like, I'm typing and I'm typing and you're typing, and some squares appear on the screen, but it's not, I don't find it as fulfilling. They want to bring physical computing in so you can do sensing and agricultural stuff, or you want to do physics projects or chemistry projects with electronics. And so they'd come to us and they'd say, we want to do this, but here's the deal. It has to be $20 a student. Because they can't afford anything more. It has to be durable. $20 a student, and it has to do everything, and they can't solder. A lot of schools, they don't actually have access to soldering tools, whether they can't afford it or because the kids are too young and it's a little unsafe. So we designed open source hardware called Circuit Playground Express, and this has all the sensors and LEDs in it. So it's got all these cute LEDs you can see. It's got a speaker and some buttons, and you can charge it over a battery, and you can plug it into USB. And we made sure it works with Chromebooks, and it works under Linux too if you want. You can use it with Arch Linux if you so choose, and of course Windows and Mac, and everybody. And what's really neat is when you plug it in, it shows up as a disk drive, which is kind of this like weird old hack because a lot of computers you can't install drivers on, especially in schools. You can't install software drivers, which is a good idea, but you end up. It's a lot of hardware kits require that. They need drivers or special software. So by having it show up as a disk drive, which sounds like such a not important decision, but ends up being the most important decision, it means that any kid, they can go to a library, they can plug this in, and they can start coding. The code lives directly on the microcontroller, and then they can build interactive hardware. And it's designed to be really durable, and you can clip to it with alligators, and it's like you can't really damage it, and like end up going through the wash, and it survives. So we did get a lot of feedback from teachers and educational institutions and people who were doing workshops that they need it to be super simple, everything in one place, and it has to be programmable by any computer. And that, some engineers don't like to be told what to do, but actually I love the restrictions because it meant I had to think, how am I going to make all these things work out and also hit that budget, right? That's what engineering is to me, is like getting it all working. And so it's really the best time now. It's never been better compared to when you and I went to school. It's so much more fun now. There's so much hardware and software, and like even though the technology is getting less hackable, like you can't really hack an iPad or Android tablet, there's a huge ecosystem of open source hardware and hackable hardware that kids can build with. So I'm actually pretty jealous. I think they're having a really good time.
Yeah, I remember when I was growing up in India, I would order my registers from different city altogether, from an electronic shop, and I'd get a packet of all those registers because you need everything, and breadboard would be there, and
which is fun, and I started that too. But it takes so much effort,
so much time.
The kids end up getting bored. I feel like if you can't get something happening within 5 to 10 minutes.
That's true.
They're just like, oh, this is too hard for me, and they get disappointed.
I have a 7-year-old, and that happens. If he cannot figure it out, with little bits also, he was like struggling, and he would. And then I got him one more kit where he had to build. I got him the Nintendo's, the VR kit where he has to build everything. I like
the
physical,
AR kit,
VR. Yeah, so I like physical toys where he can touch, he can feel. I also got him a 3D printing pen, but
those are fun.
Yeah.
I mean, you have to try different things, but I think having that immediate reaction is key. If you want to get more, there's always like that kid who has been programming since they were like 12, right? There's always that kid, and I'm not worried about that kid. That kid's going to be fine. They're going to be the CTO of like the next, Google or Red Hat. But what I want to do is get more kids who don't necessarily realize that they can become engineers or programmers. And also, as we're seeing, no matter what your industry, let's say you want to be a veterinarian, you want to be a cancer researcher, you want to do space technology, all this stuff, you have to know engineering, you have to know software. Nothing is untouched by software anymore.
Right.
You want to go and have a farm, you want to brew beer, all these things use software to manage yields, to manage environmental controls. It's all computer-based now. So you have to have familiarity with this technology, even if you don't want to become a sysadmin.
Right, and the kind of world we are going to live in, we cannot go back to coal mining. We have to find, new.
We'll go back to coal mining, but it'll be robots. Robots doing it.
Robots doing it, yeah. So we have to look for technology. But the problem is most of the time when people look at technology, they look at Facebook and iPad. They don't look at these things. So it's incredible you're doing. But how I asked Adele also, how you keep excitement. But what is your you're having fun. Everybody who is using Adafruit, they're having fun. But do you have a long-term goal? Okay, now a lot of machine learning kind of things are coming in. I was talking to the food computer program yesterday. She was talking about how they are using all these Arduino board and Raspberry Pis. So do you want to take it to the next level also beyond, or what is your goal for future,
I think that we always want to be on the edge of what technologies are coming in. So I don't think, AI or machine learning is the end of, I do see, we're working now on making a little, AI machine learning driving robot kit. Like people hear about self-driving cars. You can actually make a little self-driving car nowadays using all open source hardware and software, which is really neat, right? I mean, there's this, multi-billion-dollar companies doing it, but you can also have a classroom doing it. And we're always looking at what is the latest technology and what is the coolest thing we can build with it. And I remember reading about Square Enix, which is like a company that makes video games like Final Fantasy. And people always said, what is what is your game? What are the kind of games you make? And they said, we always just make the best game you can make with the technology available. Whether it's the Super NES or the PlayStation 3, whatever the technology is available, we're going to make the best game we can with it. And so I think Adafruit does that too, even though it's like, yay, rainbows and kids and unicorns and like cosplay, it's fun. The underlying technology is incredibly intense and complicated.
Right.
We're taking very advanced electronics and sensors, and we're making them appear very simple. But the fact that you plug this in, and under MakeCode you drag some blocks and you click download and like it syncs together. It's like, wow, that's so elegant and clean and cute. But it's like underneath, it's like there's web USB and like we're simulating the first MBR fat blocks so that like the Chromebooks don't unrecognize them, and then the data is formatted in a certain way, and we have like transpilers and like linkers happening in JavaScript. I mean, it's like this intense amount of technology to make this really beautiful experience.
Right. And hardware is harder than software, How do you keep up with new innovation in this electronics? And how do you source your material?
Well, there's a lot of companies that it's kind of like saying like, well, how do you know about the latest, JavaScript like framework? It's like, well, like everybody just knows about it. Well, it's like, because you're in this community. So
right.
Within hardware community, there are people who share and talk. We have customers who email us and they say, hey, I saw this really cool tech.
Okay.
You should integrate it, and I'll look at it and I'll see if it makes sense. And I get a lot of really good advice from them. Sometimes we'll custom make stuff, of course, but we also listen to what companies are coming out with. So we subscribe to the mailing list, so we go to their websites, or we check out blogs of engineers who are working on the cutting edge. And so we look at that and think, the tough part is figuring out like, how does this combine, right? Like, how do we mix this with the needs of people? For example, Honeywell came up with this really nice ported pressure sensor for, I don't know what it was, for some industry. When I looked at that, I said, oh, you know what? This would make a really good sip and puff interface sensor for people who use breath-controlled assistive tech. It's got a port on it, and it's got like a moisture guard. So it's like, oh, all the things that this sensor has solves a problem that I know somebody has presented to me. And so it's mostly just getting all this information, and then you just match. You just have to do this matching of what people are saying they need and what is coming out.
But another piece is that the cost. You try to keep it affordable also.
Yeah.
And new materials are usually new technology are mostly very, very expensive.
Yeah.
So
no, that's a challenge. It's like, how do you find the technologies that are also inexpensive? And sometimes I look at things and I'm like, this is really cool, but I just know nobody's going to be able to afford it, so I have to pass. But then sometimes a year or two later,
okay, that's how it works.
It comes down in price. We may not be a large enough, like the maker market may not be large enough to push prices down. But what we can do is we can, follow some big customers. So like small e-ink displays, for example, were extraordinarily expensive like 5 years ago. But then they became very common in shelf displays. Like everyone knew that they were going to be used for shelf displays, but there just wasn't a huge customer that came in and basically bought hundreds and hundreds of thousands of units that would help lower the cost. But eventually that did happen, and now the price went down, and now makers are able to, access the technology and use it without it being like, okay, I only have one display and I hope I don't break it. Now they're like a couple bucks a piece.
Right. Yeah. Awesome. Before we wrap up, I don't even know whether you have any free time, but do you have free time? If you do get some free time, what are your hobbies? What do you do in your free time?
Well, I love what I do, so I do it a lot, and I run a company with 150 people in it, so it is kind of like my life. But I actually love tinkering with new technologies. I mean, this is my hobby.
Exactly.
I kind of made my hobby, like this is what I was doing instead of working, and so now I'm just doing it. So
that means you're never working. You're just having fun all the time.
I'm having fun in between the work. But I'm here in Boston, so that's kind of fun. But yeah, we live in a city, New York. That's where the factory is, and it's a beautiful city, and there's amazing art and music and events, and so it's fun to. We went to a really cool fashion show in Brooklyn that Microsoft MakeCode was at, but it was also just an amazing fashion show of young designers who were inspired by the Herero women of Namibia to make these beautiful dresses. And that was like a really enjoyable thing because it was totally not writing code at all.
Right. Thank you once again for talking to me today, and I look forward to talk to you again.
Okay, thank you for having me. Yeah, thanks everybody.